Assalamualaikum warahmatullahi taala wabarakatuh. So, today our group will present about degradation of plastic in daily life under subject KEJ4643 Polymers and the Environment. Okay, this is our group members. Me, Muhammad Aiman bin Abdul GHANI and AMIRUL Ashraf bin ZAKARIA. Okay, there are 8 contents in our presentation. First, we have introduction, the composition, structure, and properties of plastic, abiotic degradation pathway, method, effect of accelerating condition, degradable plastic, conclusion, and last one is references. Okay, the first one is introduction. Okay, polymer degradation is a change in the properties of the polymer, such as tensile strength, color, shape, and molecular weight, or of a polymer-based product under the influence of one or more environmental factors such as heat, light, chemicals, or any other applied force. Okay, the next one is plastic. Plastic defined as polymer of long carbon chain plastic, polymeric material that has the capability of being molded or shaped, usually by the application of heat and pressure. Okay, the next slide is the composition, structure, and properties of plastic. Okay, commodity resins are plastic that are produced at high volume and low cost for the most common disposable item and durable goods. They can divide it into two groups. One category is plastic that are made up of polymers having only aliphatic linear carbon atoms in their backbone chains. And the other category is plastic is made out of heterochain polymers. These compounds contain atoms such as oxygen, nitrogen, or sulfur in their backbone chains in addition to carbon. Okay, we go for the third slide, which is abiotic degradation pathway. Plastic degradation mechanism can be classified as one of it is physical, which refer to changes in the bark structure such as cracking, embrittlement, and flaking. Or the second one is chemical, which is refer to changes at the molecular level such as bone cleavage or oxidation of long polymer chains to create new molecules, usually with significantly shorter chain length. Chemical degradation in the environment typically includes either hydrolysis, which require H2O, or oxidation, which require O2, both of which can be accelerated by microbial action, heat, light, or a combination of these factors. Abiotic and biotic processes frequently coexist, with abiotic degradation resulting in smaller molecules which are then mineralized by bacteria. Okay, the next part I will pass to my partner, Amirul Ashraf.
Thank you, Anas, for your presentation. I am Amirul, and good evening to everyone, especially to my lecturer, Professor Mohamad. I would like to present my part. First, I'll go to the method. The first one is assessing bond cleavage, which is mass loss. Degradation has been assessed using mass loss measurement in soil, compost, and microbially enhanced lab environments. The rate of mass loss is directly connected to the surface area of the plastic components because deterioration occurs at the surface. The mass of non-volatile or insoluble polymeric material is reduced as a result of partial conversion to small molecules such as CO2 and H2O and their subsequent volatilization or solubilization. Next, assessing changes in chemical functionality, which is chemical analysis. Even at low concentrations, nuclear magnetic resonance (NMR) and infrared (IR) Spectroscopists may identify the presence and concentration of particular functional groups in polymers. Ketones and ester carbonyls are indicative of oxidative breakdown routes, and IR is particularly useful for detecting them. Next, assessing changes in material properties, which is dynamic mechanical analysis, DMA. This method is commonly used to determine the strength of polymers. Physical deterioration during the polymer degradation is also shown by changes in tensile strength and elongation at break. The production of fractures and pores at the surface, as well as a drop in molecular weight, are linked to changes in these mechanical properties. Next, we go to the effect of accelerating condition. We have UV irradiation. Most polymers require UV radiation to begin photooxidation, which occurs through a radical chain mechanism that results in bond breaking and a drop in molecular weight. Because of their enhanced hydrophilicity, shorter chains, generally with oxygen-containing functional group at the chain ends, are more susceptible to microorganism assault and mineralization. Next, for the degradable plastic, plastic can be made biodegradable with the addition of certain chemicals that break down the structure of the polymer. First, we have also biodegradable. The additive are typically metal salts of carboxylic acids or dithiocarbamate, cause the plastic to degrade by a process initiated by oxygen and accelerated by light and or heat. Enzyme mediated plastic, the second one, the organic additive together with its carrier material, which is ethylene vinyl acetate, is consumed by the microorganisms, during which these secrete acids and enzymes that should break down the plastic into materials that are easily consumed by microbes. Finally, we have conclusions. We need to encourage more technologies to upgrade our plastic, since our technologies are more advanced. Then we need to work more on campaigns to promote the good ways of using plastics, such as 3R, which is recycle, reuse, and reduce. Finally, polymers should be known and learned from a lot of people so they can relate the plastics and degradation. That's all from us. Thank you for listening and have a nice day.